Hi, today we are going to see about the satellite link design. The content in this topic are design of the satellite links, link budget and their interpretations. A satellite link is defined as an station and earth station's connections. The earth station and the satellite connection is called as uplink and the satellite to earth station segment is called the downlink. The earth station design consists of transmission link design or the link budget, the transmission system design. The link budget establishes the resources needed for a given service to achieve the performance objectives. The satellite link is probably the most basic in microwave communications since a line of sight path typically exists between the earth and space. This means that an imaginary line extending between the transmitting and receiving earth station and the satellite antenna passes only through the atmosphere and not ground obstacles. Free space attenuation is determined by the inverse square law, which states that the power received is inversely proportional to the square of the distance. There are, however, a number of additional effects that produces a significant amount of degradation and time variation. These includes rain, terrain effects such as absorption by trees and walls, and some less obvious impairment produces by unstable conditions of the air and ionosphere. It is a job of the communication engineer to identify all of the significant contributions to the performance and make sure that they are properly taken into account. The required factors include the performance of the satellite itself, the configuration and performance of the uplink and downlink earth stations, and the impact of the propagation medium in the frequency band of the interest. The design of the satellite link is the RF carrier in any microwave communication link begins at the transmitting electronics and propagates from the transmitting antenna through the medium of free space and absorptive atmosphere to the receiving antenna, where it is recovered by the receiving electronics. The carrier is modulated by a baseband signal that transfers information for the particular applications. The first step in designing the microwave link is to identify the overall requirements and the critical components that determine the performance. For this purpose, we use the basic arrangement of the link as shown in figure. This is the design of the satellite link budget calculation analysis block diagram. Bidirectional communication occurs with a separate transmission from each earth station. Due to the analog nature of the radio frequency link, each element contributes a gain or loss to the link and may add noise and interference as well. The result in the overall performance is presented in terms of the ratio of carrier power to noise and ultimately information quality. Any uncertainty can be covered by providing an appropriate amount of link margin, which is over and above the C by N needed to deal with the propagation effects and nonlinearity in the earth station and satellite repeater. The link parameters impact on service quality is shown in the figure. The four factors related to satellite system designs are the weight of the satellite, the choice of frequency bands, atmospheric propagation effects, multiple access techniques. The major frequency bands are 6 by 4 GHz, 14 by 11 GHz and 30 to 20 GHz. The 30 is uplink and 20 is for downlink frequencies. A geostationary orbit, there is already satellites using both 6 by 4 and 14 by 11 GHz every 2 degree. The 2 degree is the minimum space to avoid interference from uplink earth stations. The link budget determines the antenna size to deploy, the power requirements, link availability, bit error rate, and overall customer satisfaction with the satellite service. A link budget is a tabular method for evaluating the power received and the noise ratio in the radio link. It simplifies the carrier to noise ratio calculations. The link budget must be calculated for an individual transponder and must be recalculated for each of the individual links. The satellite link is composed primarily of three segments: the transmitting earth station and the uplink media, the satellite and the downlink media and the receiving earth station. The carry lever received at the end of the link is a straightforward addition of the losses and gains in path between transmitting and receiving earth stations. The carry to noise ratio calculation is simplified by the use of link budgets. Evaluation of the received power and noise power in radio link. The link budget must be calculated for individual transponder and for each link. When a bent pie transponder is used, the uplink and downlink carry to noise ratios must be combined to give an overall carry to noise ratio. Thank you.